Hey,
Hey Alex, how are you?
good. How are you doing?
Not too bad. Did you have a chance to look at any of the videos? It's okay if you didn't.
I looked at a little bit of the start of one, but
Okay,
yeah, not really.
that's okay. So,
I know I shouldn't be making excuses, but like,
don't worry about it. I just wondered.
oh
So,
yeah.
we got to do what we can do. So, I'm going to share my screen. Let's get at it.
Okay. I
Um,
did two photos of the stoichiometry part,
yeah.
and yeah, do you want to go through that one?
Okay, this one here is all about this one's all about the mole bridge. Can you hear me okay, or is my voice echoing?
Your voice is perfect.
Okay.
What's the mole
Yeah,
bridge?
so I just sent you an email about it so that you could see it.
Oh,
And it looks like, let's see here. Let's see if I can pull it up. No, that's not going to do it. Looks like this right here on the right.
oh yeah, I did start that, and I was
Yeah.
trying to that.
So to get to one side of a reaction to another, you always have to figure out the moles to cross over from this reaction side to get over to the product side, or from the product side to the reaction side. Good so far?
Yeah, you just have to know the moles to do something.
Yeah, but sometimes the moles aren't perfectly accurate. So right here in the equation, they are perfectly accurate. So this is the perfect balanced equation, and explains to you, okay, I need 2 moles of this and I need 3 moles of this. And when we have the reaction, I get 1 mole. When you see nothing there, it's one. And I get 6 of that. And this is the only way they learned how to balance chemical reactions, because they discovered the mass didn't matter, the volume didn't matter. It matters, but it's not. You couldn't see a pattern. And then the concentration didn't always work, but the number of moles always worked. And the moles are based on the periodic table and the atomic mass.
Yeah.
Good.
A mole is like 6.1,
No,
6
no, that's the number of molecules,
in a mole.
6.022 times 10 to the power of 23
Yeah.
molecules per mole. That's a different thing.
6.022. Yeah, that's it.
So that's a number of molecules per 1 mole. You'll see down here, per 1 mole.
Uh-huh.
That's the important part. That's what we're after right there, that
So
1 mole.
2 moles, it's 12 point.
Yeah, don't worry about that. Don't worry about that. We'll get to it. Yeah, you'd multiply it by 2. Here's the other one you need to know. For every in a gas at standard, we touched on this the other time, at standard temperature and pressure, every gas, if there's 22.4 liters of it, there's 1 mole.
Yeah.
So that's the other. So those are 2 constants that you should write down or be used to. But each of them
I
has
think I have
yeah,
memorized.
each of them has them per mole. And then the other ones are based on the atomic mass. So you have to pull up the periodic table and add up the mass. So for something like this here, we would have to figure out the mass of high nitrogen and the mass of fluorine and multiply the fluorine by 3. Skip the 2 for now. Skip the 2s, skip the 3s for now. We'll
Yeah.
discuss that now. In this first question, first of all, in the reaction, identify the 2 things that they're talking about in this first question in A. What are the 2 things they're talking about in A?
So basically we have 5.5 moles of H2.
Okay, so
And
that's here, right?
yeah.
Okay, so we should focus on that. Yeah. And what else?
Wait, but that's 6 moles,
Yeah,
not five.
exactly. So we'll get to that.
Yeah.
And it's
And then
actually it's actually 3 moles, because what you're doing is you're taking 2 times 3 and you're figuring out how many hydrogens. That's not how many moles there are. This is how many moles right here. 3 moles, 2 moles, 1 mole, 6 moles. Okay. That's
yeah.
what you did, was figure out how many hydrogen elements we had to add up. We'll get to that.
Uh-huh.
For now, I want you to focus on the number right in front. This is the number of moles.
Yeah, so it's
Okay.
basically saying how many moles of NF3 will be consumed.
Right. Where's the NF3 in this equation?
It's the first one.
Yeah. So we're talking about these 2 things. So that should be your focus. Say, okay, ignore everything else. These are my 2 focus. What's the only number or information they gave you?
We have 5.5 of H2. So
Now,
then have to balance that with the
That's right. So tell me, based on the red squares I gave you, how many
yeah.
moles of H2? H2 is its own thing. So you're going to have to get used to the notion that H2 is a gas and it's part of Mr. Brinkelhoff that I sent you.
It's one of those like what are those
Diatomic.
diatomic molecules
Yeah.
that always come together?
And the rhyming thing is Mr. Brinkelhoff. Mr. Brinkelhoff.
Miss
Bromine,
Huff, yeah, I see.
iodine, nitrogen, and that should be an L. Chlorine, hydrogen, oxygen, and fluorine all come with 2.
I have an idea. This may be wrong, but if
Okay.
we put 3 over 5.5 equals 2 over x.
You're almost right. Yeah, you actually you nailed it. That's a perfectly acceptable algebraic method to do it. Fine, but I want you to and I'm about to introduce you to the same thing, but the fractions are slightly different.
Okay.
Based on the red, how many red H2, what number in the red square of H2 do I need for NF3? What's the number in the red squares?
5.5.
No, that's what the information they gave us. So I put red square around the equation up above. How many moles of H2 relate to how many moles of NF3? So I'm talking about in here, the green squares are what we're concerned about in this question. And I'm talking
Yeah,
about the red squares right here.
H2, we have 2 moles of NH3.
Right. So I'm going to write it like this. 3 moles, H2, 2 moles, NF3. Good?
Yeah.
Great.
Let me write.
Yeah. And this is a fraction. It's a relationship. Whenever I have 3 moles of H2, I need 2 moles of NF3. Got it?
Yeah.
It's very much what you were doing. It's identical, actually, but just work with me on this one.
Mm-hmm.
Now, what's the only information they give us in this question? And what about? What element about? What's the only number they give us in this thing?
5.5.
Of what, though?
H2.
Moles of H2, right?
Moles of H2.
So we can see that when there's 3 moles of H2, I'm going to get 2 moles of this. If there were 6 moles of H2, I'd get 4 moles of this. But 5.5 is weird. So we
Yeah.
have to do this. We have to somehow get rid of the word moles of H2. And they want to know moles of NF3, right? They want to know.
Let's multiply 5.5 times 3.
Careful. This is what I
And
wanted. I want to get to. So we have this. Hang on. Let me just find my thing here. We have this information here. 5.5 moles. As soon as I get there. There we go. What do they want to know in the question? How many?
how many moles of NH3 we have?
Right. NF3. Now,
NF.
in that fraction I gave you, where do you see NF3?
I see it at the bottom.
Right. Now, I want that as an answer. So here's my hint I'm going to tell you. There's 2 ways to represent this fraction. There's 2 ways to represent this fraction. This way and this way. And, let's see if I can make it a little smaller. They're the same fraction. They're just written slightly differently. One's written on top and one's written on the bottom. But they're the same fraction. There's
2
just...
over 2 over 3 are not the same
You're
fraction.
right. But the relationship between the moles of H2 to the moles of NF3 written this way, it's the same
Yeah.
thing. If I'm going 100 kilometers an hour, I can still say in 1 hour I go 100 kilometers.
For sure.
Nobody talks like this. They just say kilometers per hour. But it's
Yeah.
kilometers per 1 hour. So the reason I'm expressing these fractions in 2 ways is the question wants this answer, right?
Yeah.
That means I want to use the fraction that has that up top, and I'll show you why. So that's all I'm just going to work with me. You suggested first that I multiply this 5.5 times this fraction. But notice that this is moles of H2 in the red here. I just didn't write it. It's 5.5 moles of H2 right there. If I multiply it by this, these words don't cancel. They're both on the numerator. They're not going to cancel.
Yeah.
But if I multiply by this fraction, notice that the words moles of H2 is at the bottom,
Mm-hmm.
right? So that means this here is going to cancel with this. And what words in this fraction are I left with? Am I left with?
You're left with
What words
moles
of
of NH3
NF3,
and
which
F3.
is what I'm looking for.
Yeah.
So what I should do is multiply 5.5 not by 3, but by 2, and then divide by 3.
Oh yeah. So that would be, I'll just pull out my calculator
Yeah,
quickly.
yeah.
And wait, that's 5.5 plus 3 is 8.2 is 8. Wait, no, multiply. Oh,
Yeah,
it's
multiply
11. It's
11,
11 divided by
3.
3. Yeah, 3.666666.
Yeah, so that's how many moles of NF3 I'll create. Notice that it kind of makes sense, because if I had 6 moles of H2, I'd make 4 moles of NF3, but they gave me this weird amount, 5.5 moles.
Yeah, the 5.5 really just makes it so you can't do it in your head.
Yeah, that's exactly why they're teaching you this. You got it. So
Uh,
that means actually I shouldn't be saying, and I don't know how your teacher is about significant figures, but I should really be saying 3.7.
Like
Huh?
she says, whatever is given in the equation is what you use,
Yeah, so
unless.
I can see 2 here. So I should make it 2 here. So,
Yeah,
right? So instead of 3.666666, that
it's
6 rounds up to 7. Good?
yeah, for sure.
Now I want you to teach me B. In B, we're going to use the same technique. All right, the same technique. Only
Yeah.
in B, you're going to tell me what I'm looking for, what I have, and what's the molar fraction relationship. So what two things in the equation up here should I be focusing on? What two things?
So focusing on the other side with N2
Yeah,
and no, we're focusing on both sides at the same time.
yeah,
The 8 and the NF3.
right. So that's here and here. So we can ignore everything else. I want you to tell me how many moles of one represents the other.
6 to 2.
6 to 2, right? Oh, if we really want to get fancy, we'd say 3 to 1, but we'll just say 6 to 2. There's 2 moles of NF3 for every 6 moles of HF. And I want you to get in the habit of writing exactly what I just did.
I'll write it down now.
Now, what information do they give us in this question? I'll wait till you catch up.
Oh, we have 4.6
But here's the important part. Moles of what?
HF.
Right. Now, what are they looking for?
NF3.
Right. We don't know that. Which one has NF3 at the top? If I were to write the fraction like this as well, which one has NF3 at the top?
Uh, the second one.
Right. So I should use that because my question wants this part as an answer.
Yeah.
Great. And
So
you can see what words would cancel out if I multiplied this fraction by this. What words cancel out?
the words to cancel out that are moles
Of
of HF and
yeah,
HF.
that's the
So
important part.
2 times 0.47 over 6.
Yeah, that'll tell you the moles.
I'll do that in my on my calculator now.
Yeah, and this is the mole bridge. This is what we use the mole bridge.
0.94. Okay. We have 0.16.
And does it continue?
It does. It's actually 0.15666,
Okay,
but
good, fair enough. And so you round it up to
16
yeah. And now we've got to use the words because you'll lose marks if you don't. What do I say?
of NH3.
Yeah, exactly. NF3. Exactly. And that's how you get full marks. Your teacher wants you to understand this relationship, which is represented in the equation. And he wants you to understand how to get from an amount that isn't perfectly 2 to 6. How do you use these? And this is how.
Yeah.
because the fraction here will always represent the ingredients in this recipe. And so you're able to find weird numbers using this fraction. Good?
Yeah. Let me just
Yeah.
finish right.
You go ahead. You let me know when you're ready.
There we go. I
Now,
got it.
notice what units we've been working in over and over again. It's moles, isn't it?
Yeah.
Over and over
Mol
again, moles, moles, moles. But notice that I talked earlier about the mole bridge, and I just want you to look very quickly at what I was talking about. I'm just going to copy the image, bring it over here. Notice that sometimes it's got moles in the middle, which is what we're working with. But it looks like sometimes we take mass, we got to divide by molar mass to get moles, and then we've got to do other stuff to get to mass. Looks like there's going to be more methods than just moles and just working with moles.
Wait, so if we multiply
Well,
molar mass with
this thing shows you the general methods to get from one side of an equation to the other through moles, because we have to use moles to get from one side of the equation to the other. So it's showing if I start with mass, this is the path I take. And if I'm trying to get to mass, I got to go this way. And it's showing me even the multiplication or division. If
wait,
I,
and then if you're trying to get to like mass to to particles, how do you
right.
do?
So you got mass divided by molar mass will give you moles, and moles times Avogadro's constant will give me the number of particles.
Oh, I should write this on my arm.
Yeah, I sent it to you on in your email.
Yeah.
It's called the mole bridge.
It'd
So
be so fun
we'll
to
keep
go to exam with like a huge like shirt that's just like chemistry nerd and like all the things on it.
yeah. So usually people make little crib sheets like that to get ready, and it's pretty common. And you're gonna save yourself some hassle just by understanding. Oh, every time I have to sort of do this method. And when they give you these questions coming up, it's just to practice getting
One way.
there. Now, I want you to identify on the mole bridge on these next questions. Now that you've gotten used to this, simple moles, now I want you to look at this next question and ask. I'm going to zoom in, don't worry, and ask, what are they doing slightly different? What do you notice slightly different? What wording do you notice?
Grams instead of moles.
So
So
we're
we got
doing mass, but fortunately, they're still looking for moles, so I don't have to do any of this stuff after. I just need to convert mass. I need to divide it by molar mass. I'll get moles, and then I got to still use that fraction stuff we were doing.
yeah.
So
Okay,
let's,
well, mass is 1.0, no, 180.6 of
yeah,
N2. And the
right.
mole of N2, I gotta find that quickly.
So 1n is 14.
Okay, so it's 28.
28, that's right. So now notice they've given us mass. There's an indication, what do I do with something? So what do I do?
180.6
Yeah,
divided by 28.
yeah. And that'll give you the number of moles. Makes sense that there's going to be more than one mole. What?
6.45.
Great. So now we have moles. Be careful here. 6.45.
6.45.
Don't round up yet. So now we have that, but it's moles of N2. And notice the question is asking for what?
How many moles of H2?
So we need to go up here and see the relationship of moles between N2, the thing we found, and H2, the thing we're looking for.
Yeah.
So where is it up here?
Well, we have 3 H2s to every one N2.
Right. So let's write that as a fraction. Let's call it, we can just even shorten our words moles of and just do this like that. 1 and use H2. Now, in our question, and I'm going to go back to our question now that I have our fraction. What are we looking for? What's our final answer? What are we looking for?
Moles of H2 would you need if we have 6.45 grams of N2?
Yeah, so notice that. No, we don't have grams now. You've already converted it to
Oh,
moles.
6.4 moles.
So
Okay.
now notice that H2 is on the top, and that's where we want our answer to be. So we should multiply by the fraction that has H2 at the top.
5 times 3, and that'll be our answer.
Yeah, and notice that N2 cancels out. N2 here, N2 here. And I'm left with moles of H2.
Okay, I'm gonna write this down.
Does it make sense though?
This one definitely does. $6.45 times 3.
Mm-hmm.
19.35.
Yeah, and we'd have to round up because we've got 4 sig figs, but fortunately
Oh,
we got 4 sig figs. So that's good.
only have threes. No, we have
No, we started with 4 right there.
yeah, 19.35. We're chilling.
Yeah. Now, you should also answer the way they want. They said how many moles of H2 would you need to start with? You
Yeah.
would need 19.35 moles of H2 to produce 180.6 grams. That, if you have time, that's how they want you to answer. But notice it looks like here you just write in the answer right there. But if you're doing formal university stuff, that's what they're looking for.
I'm not trying to do chemistry in university.
Oh
Okay?
no, what are you doing this for?
I'm I just need to do chemistry.
Okay,
But
fair enough.
one thing, I forgot to sign in to my house, and I'm like 7 minutes
Go for it.
late.
Go for it.
I'll be back in 1.5 minutes
Go
or less.
for it. I'll be counting the minutes, so don't be late past 1.1.
Time for a quick Instagram scroll. Hey, bro.
All good timing.
I made it.
I did 6 Instagrams.
Oh yeah, 6 good scrolls.
Yeah.
I
So
love it. Time.
so here's another question. It's D. Now
Okay, D.
we don't have to do all this. We can skip if you get the idea, but let's
I
see.
think I get the idea of
Okay.
this.
So now I just want to notice that this one is going from mass to mass. So you have to do mass divided by molar mass for NF3 to find
Oh
out the
yeah.
moles. Then you have to do the mole fraction thing to find the moles of HF. Then over here, to get the mass, you have to take the moles of HF and multiply by the molar mass. That's why they have the multiplication symbol,
Oh yeah. I see.
right? And the reason you have to multiply moles by molar mass is because molar mass is always in grams per mole. So if you
Mm.
multiply by moles, the words moles cancel out, and you're left with grams, which is a mass. So this is why molar atomic mass times times moles will give you mass. Good?
Yeah.
Do you need to try it or are you good?
Atomic mass times moles equals mass.
So in this question, because we have mass to mass, I have to start with my mass, divide by atomic mass to get moles of NF3. Then I have to use my fraction to get moles of HF. And then I have to multiply that by the molar mass of HF to get the mass of HF.
Yeah, that makes sense.
You need to see the steps, or you good?
I think
Yeah. We should move on because there's a lot to do.
there's lots to.
Yeah.
Okay,
Now, oh, I just had that. There
given
we
that
go.
the first equation. Okay,
Now I'm
this
just going to briefly look at these, and you tell me in terms of the mole bridge what we have to do. Okay, ready? Each one steps it up. They step it up each time. That's all they're doing. Okay, so this one, tell me what they start with and what they want to end with. So they start with what?
okay. Well, in number A, they
Yeah.
start with 3.56 moles of HBr.
Mm-hmm.
They want, and then how many liters? So it
Mm-hmm.
goes to liters now.
Right.
Of Br-2 will be formed at STP.
Now I've
Okay.
circled the thing. What's the mole fraction? Like, what's the mole relation? I've put red squares.
It's 5 to 3.
5 moles of HBr to 3 moles of Br2. That's right. Notice Mr. Br2 is part of Mr. Brinkelhoff.
Yeah, so we should have 2 moles of Br. No, 2 moles.
Well, like 3/5. Yeah, it's going to be about 1. Yeah, around there. It's going to be. I've got 3.56 here, so it's going to be less than 3.56 here. It's going to be about 2. You're right, about 2. But then notice here, to go from moles to volume, what do I do?
Times it by 22.4.
Yeah, because it's
If it- yeah, if it-
22.4 liters per mole. Got it. What about this? Notice this. In order to produce this many molecules of Br2, what mass of HBr is needed? So I got to go mass to moles to moles to molecules. So maybe we should,
Mass to moles to moles.
yeah, maybe we should do that one.
Okay.
What's the mole fraction first between Br2 and HBr again? I think we just did it.
HBr is 5
Right.
and Br2 is 1.
Right.
2.
2. All right.
No, it's
2. 3. You're right. 3.
okay.
There we go. Now, they gave me number of molecules of what?
They gave us the molecules of HBr. 5.
No, they didn't.
Yeah, they did.
In
Oh, in the
order to produce 3
one,
point,
they gave the molecules of Br2.
yeah, they gave us 3.31 molecules of Br2, right?
It's 10 to the 24.
Right. So
Molar
now,
mass is 10 to the 23. So, yeah.
now here's the relationship. There's 1 mole for every 6.022 times 10 to the 23 molecules. They've given us what? They've given us molecules, haven't they?
Yeah.
And I want to always convert to moles to cross the mole bridge. So would I take this and would I multiply it by this fraction? Or would I take this and would I multiply it by this fraction, the upside down fraction of that?
Wait, multiply.
So this is how many molecule. This is called a constant down here. This is Avogadro's constant.
Avocado.
Yeah, he's a weird guy. He sounds like avocado. And then if I'm trying to convert that, remember we're always trying to convert to moles to get to the other side of the equation.
Yeah.
Do I multiply it by this fraction or do I multiply it by this fraction, and why?
You multiply it by the 1. No, wait, the 1 won't do anything. Yeah, no, you multiply it by the 1 mole. Yeah.
Yeah, that's because this over here is a number of molecules. They told
Yeah.
us number of molecules, and I want it to cancel out with the word number of molecules. So yeah, I would have to multiply it by this fraction over here. In other words, I have to divide that by this. Let's see how good you are with exponentials in your calculator, because it's going to be worth it. I want you to take 3.311 times 10 to the power of 24, and I want you to divide it by 6.022 times 10 to the power of 23. There's a simpler way, but let's just see if you can do it. Do you know anything about when two things have the same exponent? Yeah?
The same exponent. So to the power of 24, instead we make it 33.11 divided by 6.022.
Yeah, sure. Yeah, that's one way of doing it. You're saying that this just becomes times 10 and this disappears, right? Right? And you're saying it just becomes 33.11 divided by 6. You're right. Yeah, you simplified the fraction.
5.498
Yep.
times to the power of 23.
No. You just canceled all the powers. You don't need to bring them back at all.
Oh, true. That
Yeah.
is just 0.498.
Yeah, 5.6498.
Yeah.
And that's the moles. That's the number of moles of HBr because we had the number of molecules of HBr. So we just forgot to write it. We should have had over here molecules of HBr so that we end up with the word moles.
Yeah, we need to get rid of the 6. It's just 498.
Oh, okay. Don't ever round up until you're done, by the way. Don't round up anything till you're done. So here you are, and they want to know, and I'm just going to get rid of it. They want to know, let's go back to the question. Yeah, I think I got to pull all of it back up. There we go. No, that's
So
not.
they want to know how many moles of HBr react to make, no, if we have 3.56 moles of HBr,
Mm-hmm.
how many liters of Br2 will be formed?
No, we already did that one.
Oh, shoot, sorry.
We're right
Oh,
here.
in order to produce this many, the 3.311 times 10 to 24 molecules of Br2, what mass of HBr is needed?
Right.
So the molar mass of HBr needed is just 5.498 moles of HBr.
Almost. So we have HBr, and they're interested in what? We have Br2 rather. See, no, we wrote the wrong thing down. We have moles of Br2, not HBr, because we worked with the molecules of Br2, and from that we find the moles of Br2 when we multiply or divide it by Avogadro's constant.
Oh, so then it's just what we were doing in question 1.
Yeah, that's right. So we have 5 moles of HBr's represented by 3 moles of Br2. Like
yeah.
this.
And then we
Okay.
multiply the 5 times the 5.498
Yeah.
and divide by 3.
Right. And then we end up with moles of HBr.
Yeah.
But they don't want moles. Look what they want.
They want liter.
Nope.
Oh, wait, no.
Read your questions always.
I read it and then my brain tripped or something.
Yeah, it's right. We're down.
Oh, they want the mass in grams, so then we gotta convert moles to grams.
And what do we do? Let's look at the bridge.
Yeah, I gotta print this bridge.
I sent it to you in email, so just print it.
Oh yeah.
So what do we do? It's explained right here. How do we get to mass? You can see mass
For
on
moles, mass, we multiply by the molar mass.
Right. So we'd have to figure out the molar mass of HBr, which is 1 plus bromine.
The molar mass of, I'll pull up my periodic table. The molar mass of H is 1,
Yeah.
and the molar mass of Br is, trying to find Br on
Br is on the right side. It's going to be part of the 7th column.
Oh, there it is. It's 79.9.
Mhm.
So 80 on the.
Well, you don't want to round up that 0.9, so it's going to be 80.9. Yeah, I think you might have said that. So you're right. You just multiply this by 5, divide it by 3, and then multiply it by the molar mass, and you end up with mass.
Yeah.
Notice that this one, slightly different. It's not on our molar bridge, so we should probably do it. It's not on our mole bridge. They give you a different unit here.
I'm a little confused by what you just said by it's not on our mole bridge.
Yeah, exactly. So if I look at a mole bridge, we're going to spot why it's not on the mole bridge. They're suddenly mentioning this thing. That's not a concentration. That's not on our mole bridge. Do you know what that big M means?
That means moles.
Nope. No, that's little MOL. Moles will always be represented as this.
Oh, wait, mass.
MOL.
No,
No,
wait. What?
no.
I have no idea. What is it?
Yeah,
Oh,
it's a bummer. It's concentration. And concentration is based on something per volume, and it happens to be moles per liter. So it's the number of moles in liter. So they're telling me 1.5 big M. They're really telling me there's 1.5 moles for every 1 liter in this particular substance of HCl, which is an acid.
yeah.
Okay, and how would I get to moles if I have something moles divided by liters? Let's see if you can guess.
You divide it by liters.
If I were to
Wait,
divide it by liters, I would end up with the unit moles per liter squared.
and then oh,
And I don't want that. I want to end up with the word moles.
moles. Well, we look at Avogadro's bridge.
Yeah, we would, but that's molecule. So what do you see down here? What do you see down here? We want to end up with this word, so we want to get rid of whatever unit is down here. What unit do you see down?
We multiply both by liters.
By liters, that's right. Is anywhere do they give us liters?
They give us 50 milliliters,
Which
so
is
then
how many liters?
0.015
And
liters.
by the way, you can always use the same fractionary technique. There's 1,000 milliliters per 1 liter, which since the milliliters up top and I want liters, I would say it's 1 liter per 1,000 milliliters, right? And then I can just say, okay, well, 15, I want to end up with liters, so I'm going to multiply by my 15 milliliters so that the words milliliters cancel out and I'm left with liters. In other words, I take 15 and divide it by 1,000. So this fractionary thing works for conversions of any kind. So you're right. I would take that 1.5 and I would multiply it by 0.015 liters. The words liters will cancel. And I'll be left with moles. What is 0.015 times 1.5?
0.015 times 1.5 is I'm not sure. I need to do it on my
You
calculator.
definitely need to do it on the calculator. There's a lot of 15s in there, but there's a lot of decimals too.
0.015.
Yeah. 0.015 times 1.5.
225.
Right. So I end up with, I find out after the liters cancel, that's how many moles of HCl I'm dealing with. Okay. That's how many moles of HCl I'm dealing with. So that's important. Now I can work with the mole bridge. Okay. So I can get rid of all that crap. There. What are they looking for? I know what I have. What are they looking for?
They're looking for wait,
We're right here.
the mass of MgCO3.
So I should probably look up the relationship in the equation between MgCO3 and HCl, right?
Yeah, HCl is it's 2 HCl to every 1 MgCO3.
Yeah, it's 2 moles of HCl to every 1 mole of MgCO3. And I want to end up with MgCO3, right? I want to end up with moles of Mg, because this is where we're crossing the mole bridge. We've converted the concentration to moles, and we're now back to the mole bridge. It's just concentration's not on that mole bridge. So which fraction do I use? Do I use this fraction? Or do I use this fraction to multiply this? And why?
Just to give me a minute to look at it.
Yeah.
Yeah, so right now we can just cross out the mole of MgCO3 and the mole of HCl, and we just get 2 over 2, which is 1.
No. You can't cross out anything that doesn't match. So the words moles of HCl don't match this. This is a fraction that I've come up with from this equation. This is the same fraction that I've come up with this equation. This is what you figured out from the concentration of HCl. I need to convert this to moles of whatever we're looking for, MgCO3, before I can ever come up with mass. This is the whole point. We got to come up with moles. I'm asking you, I multiply this by a fraction. Which one?
So basically, we have 0.0225 moles of HCl.
Yeah.
On this thing up here, it's 2 of HCl.
Hmm.
So that times 2 over 1, which is the MgCl3.
Well, okay, so you're saying right here, this is why I want to teach you this fraction method. Your answer is incorrect because I can see HCl's at the top. It's not going to cancel with the words HCl if it's both at the top, right? And I want to end up, I said I want to end up with moles of MgCO3. And early on, I said you always want to use the fraction where the thing you want to end up with is at the top of the fraction. So if I were to multiply it by this fraction, I would end up with the units this, moles squared of HCl over moles MgCO3. I don't want to end up with that. I just want to end up with the words moles of MgCO3.
Okay, let me think about this one for a second.
It would be easy if I told you there's 2 moles of HCl, right? Then you could just say, well, that means I make 1 mole of MgCl2, right?
Yeah, so
So if I told you we had 2 moles of HCl, how many moles of this would I make?
we'd have 1.
So what do you do to the number 2 in multiplication or division to get 1?
You divide it. Oh, so we just
Oh, not that one. This one. Right? So you're saying multiply by 2. You really divide it by 2.
I'm getting a brain fart right now. We divide, or I was
So,
thinking, because we have 0.0225 moles of HCl,
yeah.
and on the top it's 2 moles of HCl to 1 mole of
Hmm.
MgCl2.
But I've
So,
represented the fraction 2 different ways here, Alex. That's why I've been trying to teach you this fraction method.
oh, but that doesn't, I just feel like that doesn't work if we represent the fraction this way.
Why? So if you were twice as tall as me, or better yet, if I'm 3 times your age, I can represent it like this. Peter is 3 times the years of Alex, and Alex is, or let's just say this, Peter is 3 times older, Alex is 1 time older. But I can flip that fraction upside down. Alex is 1 older, Peter is 3 older, and it works as a fraction
Yeah.
1/3 as well. It doesn't matter. It depends what I'm looking for.
Yeah, so basically, I get it. I can't draw on your screen here, but
Yeah.
we multiply the 0.0225 of HCl by the 1 mole of
Yeah.
MgCO3 or 2 moles of HCl.
And the reason we do it
That's,
is so that we can cancel out. That's why I want you to work with units, so that we can cancel out that word and we're left with the words we need.
yeah, I'll do the quick division.
Yeah.
Divided by 2 equals, so now we have 0.01125
Yeah.
moles of MgCO3.
Yeah. We're almost there, except we're not looking for moles um, of MgCO3. We're looking for mass. So now you can look at your mole bridge and say, how do I?
Multiply that by the molar
You
mass and
got
we
it.
get.
There you go. Good enough. Now,
Okay, let me
B,
write this all down so I could look back to it.
I've recorded. I sent it to you, but recordings take a while to go through.
Yeah, I think it's easier if I just write it down now.
Sure, if you can remember. The other thing you can do if you don't like this fraction method is you could say, well, if I had 2 moles of HCl, I would need 1 mole. I would produce 1 mole of this. How do I get from 2 to 1? Oh, I divide it by 2. So I must divide this by 2 to get there. You can always do it a simple way, but your teacher's going to want to see that you understand how to use the mole bridge. And trust me, it gets more complicated. Well, no, you're done, right? It's the end of the year.
Yeah. Okay. And then, yeah, so now we multiply by the molar mass, which I gotta find the molar mass
That's
quickly.
okay. You can do that on your own time.
Okay.
You're completely correct. But we have a lot of questions to go through, right?
Yeah, I agree.
Okay. This one's very similar. It's a little bit tricky because you can get hung up on the first bit of information. Instead, I want you to focus on the last bit of information. We want to convert 37.935 grams of magnesium carbonate into moles by dividing by the mass, molar mass, atomic mass of MgCO3. So essentially, grams to moles.
Yeah, so we need to know the volume of two
No,
moles of.
no, no. So that's why I'm saying don't get hung up on this part. Focus on that part. Because that we can figure out moles, right? We have grams and we know the molar mass. So we can figure out moles using the mole bridge. So let's look in the mole bridge. How do I go from mass to moles? What do I do?
Um,
Here's the mole bridge.
we multiply by molar mass.
Here's mass, and what symbol do you see here?
Oh, we divide by molar mass.
All
Yeah.
right. It's always mass divided by molar mass to get moles.
Okay,
Okay.
so we always need to know the molar mass, so I'm gonna
Yeah.
figure that out. So magnesium carbonate is
So carbon is always 12 and oxygen's always 16. Magnesium's in the very second column. It's 24.3.
yeah, so 24.3
Plus 12 plus 48.
plus 12, wait, 12, and then that plus
48.
48. I'll
What's
put that in my, oh wait, that's 60 plus 20 plus
You
4.3,
got
which
it.
is point 84.3.
Right. So now I have to do is take 37.935 and divide it by that.
Yeah. 37.355. Okay.
It should be less than a mole because it takes 84 grams to make a mole.
I'll put that in my calculator
Yep.
now. That equals 0.45 moles.
Yep. That's right. Now, my question to you, looking at the formula, what's the molar relationship between HCl and magnesium carbonate?
We have two HCl to every one magnesium carbonate.
Right. So if I told you I had 1 mole of this, how many moles of HCl would I have?
Out of two.
You'd
If you
multiply it by 2, right? You multiply it by 2, right?
yeah.
Well, then I have this, so I should multiply this by 2 to figure out how many moles of HCl I have, right?
yeah.
Okay, so
So that's the volume of 2 moles of HCl, which would be needed to react completely with
Yeah, but
that.
don't get hung up on that. We got to find the moles. So how many moles, you just told me, if I had 1 mole of MgCO3, I'd multiply it by 2 to figure out how many moles of HCl, right?
Yeah.
How many moles have you calculated you have of MgCO3 just now?
0.45
So what would
moles.
you do with that to figure
I'd
out?
multiply that by 2 to get
Right.
0. I
9.
no, but I'll
Well, hang on. Just
zero
that.
point 0.9.
Yeah. So that means we would need zero point 0.9 to create this many moles of MgCO3. Now we can work with what they gave us. They gave us a concentration. Do you remember what I told you the big M actually stands for? It's something per something.
Wait, the big M stands for, oh, shoot. Wait,
Don't, you can say shit, by the way. It's
I
okay.
said shoot.
I know, but you can say shit. It's okay.
Oh, okay.
I'm not gonna penalize you
Careful
for that.
around some people.
Yes, exactly. But I understand the frustrations of chemistry and math. You can say shit.
Okay.
Realize that everything's just a process. Once you learn the process, it's easy.
Yeah. So now
Concentration. I think
calculate
he
the
said
volume. But now we
Yeah,
need
there's
to
a
do
You're right. There's a volume in there.
the times 22.4.
Yeah, no, let's not get hung up on that. That's a gas volume. Don't be careful. We've got to focus on this big M. And I tried to explain before, so I'm going to tell you again. Big M is the same. Whenever you see a big M, I want you to replace it with this. It's actually moles per 1 liter. So they're telling me I've got 2 moles per 1 liter, or I want 2 moles of 1 liter per 1 liter. What did you
Oh,
figure out? You figured out this many moles here. And the
yeah.
question wants volume, which is liters. So this
Oh,
is
yeah.
not
So
a gas. Aqueous here, you got to check it. That's not a gas. So you can't use 22.4. That's only for gases.
yeah. So now we have to times 2 moles over 1 liter by 0.9 moles of
Oh,
H.
but what word is here and what word's at the top of
Over
that
that.
fraction? And what word do you want to end up with?
I want moles to cancel out.
Right. So I should actually do this fraction.
Yeah, and that'll give us 0.9 times 1, which is 0.9, over 2, which is
Yeah,
0.45.
we're back to 0.45, but now we know it's 0.45 liters. So that means calculate the volume, which would be needed to react completely. The answer is 0.45 liters. Be careful with that 22.4. That's only for gases. So you had to look at this and say, this isn't a gas. The AQ up here means aqueous, which just means essentially liquid in water.
Mhm. I'm
Anything
just
with a
gonna,
G is gas. But yeah, you can't use 22.4 for this one. So these questions were all about the various routes to take across the Mole Bridge.
so our answer is 0.45
Yeah,
liters.
we ended up right back where we started from. Yeah. A lot of multiplication division to get back to 0.45. But yeah, that's the whole point. They want you to be able to take the paths needed across the Mole Bridge. The more you practice it, Alex, the easier it gets because it gets pretty frustrating, especially when you try to do too much in too short a time. And the night
Yeah,
before your exam, get a good night's sleep. I know it's tempting to cram all night, but get a good night's sleep and eat a good meal because your brain won't work well otherwise.
smart. Cram now.
Cram now, yeah, pretty much. It always feels like you're cramming. Are you going to university?
Gap year first.
Good. That's smart. More people succeed with a gap year than the statistics show you. More people succeed with a gap year.
Is that actually
Yeah,
proven?
yeah, it's proven.
Well, it also does make sense because if you take a gap year and then you go back to university after a gap year, you're probably not going to drop out.
You also
But if you,
sort of know what you want to take more likely as opposed to rushed.
yeah,
But yeah, and also people take the time to earn a bit of money or just sort of figure out what do I want to go. So these are all titration questions, and it gets excess and limited amounts. It's pretty tough. A lot of these questions are almost EA2, like the next year of chemistry. So I'm just
well,
trying to figure out what you want to focus on here. So that's titration, then the one's in excess. This is about identifying whether things are double displacement or what kind of reactions going on. This is converting these reactions into heat, sort of using the same mole methods we were just using.
yeah.
So it all depends where you feel you're really weak, right? We got a lot of questions in just this session and the next one. We did this one, I think, so that's good. And we did a couple of this,
Yeah.
so that's all right.
I'm just going to read this question and then think about it for a second.
Yeah, there's quite a few. And I gave you a video on balancing.
Oh yeah, I kind of understand how to balance.
Good.
Get a little bit confused. Like, did I say, yeah, so for the first one, I
Hmm.
have no idea how
Which
to
one?
balance. And I've been going at it for so long and
This one?
it makes sense. The first one seems unbalanceable.
This one?
Yeah.
Yeah, it's a bitch. Yeah, for sure. Ready?
So yeah, couldn't get that
Re
because it was,
well, you ready?
yeah, I couldn't get the N and the O
Yeah, I hear
to,
you. It's horrifying. Um, I'm not sure how good your algebra is, but we can try this because I actually think it's a better method than trying to keep going back and forth. Ready? You know that you're going to have to put a number in front of each of these. Agreed?
yeah,
I'm going to,
definitely.
instead of putting a number, I'm going to put A, B, but it just represents this mystery numbers we're looking for. Do you see what I did? I put an A, B, C, D.
Yeah.
And then
ABC.
I just wrote them. Then I went back here and I started with my first element right there, N.
Yeah.
Okay. And I'm going to just put N, my first element, N. And I'm going to look at A. How many N's are in A? So when I say I'm looking at
One.
A, yeah, one. So I'm going to say 1A. And do you see any in B?
No.
So I'm going to hit an equal sign, which represents the reaction arrow. Do you see any in C?
No.
Are you sure you don't see any
Wait, no,
N's
there's
in?
one in C.
So I got 1C. So I got 1A is equal to 1C. Do you see any in D?
No.
Stop. We're done that one. Now I'm going to look at my next element in my whole series. So I'm just going to jump from element to the next element. That's
Yeah, so
H.
3H, so 3A
3A. Yeah.
plus,
None in B.
yeah, equals 2H on D.
Yeah, so 2D. So we got 3A is equal to 2D. Great. What's my next element as I go left to right?
We have um
So
two.
I'm doing like this. I'm going
Oh, for O we have
nitrogen. Yeah, there you go. Oh,
equals
what did you say? I couldn't hear you.
2B,
Right equals.
1C,
Ah, but this time we can
and
also see
plus
there's
1D.
1D. So we do 1C plus 1D. And our last element, that was it. So that's great. Now, here's what you do. That's all you do for that. It's pretty simple. Yes?
Yeah,
Okay. Then you're just going to say, we're going to make A equal to the number 1. So we're going to start with our first equation. Our first equation was 1A is equal to 1C. Agreed?
mm-hmm.
But I'm going to make A1. So 1 times 1. See what I did there? Instead of 1 times A, 1A, I'm just going to make A1. 1 times 1. Yes?
Yeah,
So I got 1C is equal to 1. So what does C got to be?
1.
Great. Good. Next equation. 3A, but I just said I'm going to make A what?
A is equal to 1.
Right. So 3 times 1 is equal to 2D. So I got 3 is equal to 2D. How do I get D all alone there?
Um, D, wait, what do you mean by get D all
Yeah,
alone?
so this 2 is actually multiplying this letter D. How do I get rid of that 2 that's multiplying D?
Oh, divide both by 2.
Right. So I got D is equal to 3 divided by 2, which is 1.5. Good. Just
Wait,
forget
are we
that.
allowed to use 1.5?
Just work with me, Alex. Just let's keep going. So,
Wait a minute.
I got 2B. I don't have a B letter. 1 times C, but look up above. I figured out what C is. What is C?
C is 1.
So 1 times 1 is 1. Plus 1 times D. I got D is equal to 1.5, right?
Yeah.
Okay. So this adds up to 2.5, right? So I got 2B is equal to 2.5. How do I get B all alone? 2 times B is equal to 2.5.
To get B all alone, we need,
So
wait,
it's
2
2
times
times
B.
B, and I'm trying to get rid
Oh,
of
we
that.
divide by
So
2,
I got
so then
2.5 divided by 2. Let's just leave it like that. Now let's go back up. We're all done. That's what B is equal to. Now, A is fine. It's a 1, right?
yeah.
C is fine. It's a 1. D is a pain. It's 1.5. So we're going to multiply everything. We're going to try to get that into whole numbers. So
Multiply it by 2.
but we got to multiply everything by 2 if we do that. So this becomes 2, this becomes 2, and this becomes
3.
right? What does this become? This is 2.5 over 2 times 2. So it's 2.
2.5.
Yeah, great. Great. Now I've got my A is 2. That's fine. C is 2. D is 3. B's a pain. It's 2.5. Guess what we should do to all the numbers now?
Multiply them by 2.
Right. So A becomes 4. C becomes 4. D becomes 6. B becomes 5. Boom, you figured out all the numbers.
Yeah, so now A equals, so it's 4,
Right.
4, 6, 5.
Almost. Look what your B is.
Oh, wait, 4, 5,
Right.
4,
Right.
6.
Right. So now I can get rid of all those letters and just slide those numbers down instead.
I've never seen it done that way.
It's kind of good when you have a complicated one.
Yeah, because that one I was just messing around for a while and it just
And
wasn't.
you know what? If you do that during an exam, here's what happens. Oh fuck, I'm running out of time. I'm running out of time. I don't know, and then it screws up all your other questions. Because you're going, oh, that other question's bugging me. I can't. Okay, I'm gonna keep going. Oh, that other question. I know I had it, and you waste 20 minutes on it. You go, and it ruined. So here's the other tip: eat breakfast, sleep well. Sorry, I swore there. Eat breakfast, sleep well, and do the easy questions that you know for certain first. Like jump around the exam. Go, oh, I know
Yeah.
that. I know that one. Because
Like
you're
what I did on my pre-calc exam was I went through and just did everything I knew.
That's right.
And
Because then your brain goes, "Oh, I'm steaming along here," and your brain
yeah,
gets
and then
confident.
after that, I went through again and then I remembered some things
Yeah,
because I had 20 minutes for my brain to work it over as I did the other.
that's right. It's called your brain unlocks, and it works on things in the background.
Yeah, because my brain knows how to do everything.
Yeah, it's just
So
people panic.
if I learned it at some point.
Yeah, people panic. So that's how you can balance any equation. It works for any equation. When you're faced with 2.5, just multiply it by 2. If it's
Uh-huh.
something divided by 3, just multiply everything by 3. And then,
Yeah.
sometimes you might end up with this, right? You might end up with 8, 10, 8, 12. And you can say, oh, wait a minute. All those are divisible by 2. So you can just say, oh, wait, it's 6, 4, 5.
Oh yeah, I get it.
Yeah.
Because
You want to
yeah,
simplify it.
put it in
Yeah.
most simplified form.
But all these questions on here can be solved with the algebraic method I just gave you.
That's
Now,
good.
if there's an easy one, sure, just take it the old-fashioned way and just do it the easy way. If you can solve, but as you notice, this one was a pain. And if I look at this one, I'm going to guess that this one's going to be a bit of a pain too. Just because that AL gets turned into 2 here, and I can see lots of C's around. I don't know. Some of them you can spot as a pain, and some are going to just be very simple. Like this is going to be simple. And the interesting thing is you're going to see a relation. What's the relationship between 3 and 2? Well, it's 6. So I got to multiply this by 3 and this by 2, which means that this is probably, oh, it doesn't work. Now I need twice as many. So this is going to probably be 2, and this is going to be 6, and this is going to be 4. So now I'm still off on that. I'm going to have 8, probably 8 there. And then that's going to be 24. So that means this is going to be 12, 8, 2. And then that still is too much. I can just go 1, 4, and I think it was, what did I just say?
Oh, it's just A is 0 or 1,
Yeah.
B 6, and C is 4. That was the only one I did other than the first one.
Yeah. There you go.
Because yeah,
So
that one I could do in my head.
that's right. So these easy ones that you can do in your head, don't bother with my method. But the more complicated ones, just whip out the algebra and go through it. Doesn't take too long if you get good at it. Okay. I want to do one of these just to see if you know how to do them. Oh boy, these are the tough ones, by the way, down here. Students always have trouble with the words in excess or limited. But I want to do this. When we're mixing two acids, when we're mixing an acid rather and a base, Especially, they're always going to give you a strong acid and a base in this level of chemistry. So there's a strong base, and let's see. Oh no, this is a double displacement. Okay. And oh yeah, this is an acid, this is an acid, this is a base. So we're looking at a situation where we're got to convert this to moles again. Do you remember what I said about big M? Let's see if you can remember.
That's concentration.
Oh, what's the actual units instead of big M?
Um,
Something per something.
moles over liters.
Yeah, you got it. It's going to come up a lot. So might as well get used to it. It's going to come up a lot. Concentration comes up a lot. So really, this is the same thing as big M. And I can see they've given me a liters that's tied to that. They've given it milliliters, but it's still liters, which means I can figure out the moles. So I want you to always remember, if I take concentration and multiply it by liters, I'm going to get moles.
Yeah.
Okay, so if I take this and divide it by the liters that they've given me, what do I get? Or multiply it by that. What do I get? 0.3 times that.
Oh, when you take 0.300
Yeah,
time, you cross out the liters
yeah,
and multiply it on my calculator right
yeah,
now.
yeah, excellent.
0.00546.
0.00546 moles of BaOH. That's what we're working with.
Yeah, I'm just gonna write this all down.
Yeah. So they gave me the concentration and they gave me the liters, so I could figure out the moles. And guess what? It's very much like the mole bridge we were doing before.
Wait, I can't see. I was about to
Oh,
write it down and now it all
what
just.
happened? What happened to it? It's not there? Oh, I see. Sorry. Yeah,
Oh
there we
yeah.
go. There we go. Let me just make sure I don't lose that, and then I'll just get rid. There we go. Concentration times liters will always give you moles. Concentration times liters
Yeah, and
will
then the
all.
answer we pull. Oh wait, the
Yeah,
not equal.
here's the answer. Yeah. Well, that many moles. This is what we came up with. Good?
Yeah, of BaOH.
Yeah, it's BOH2, but I just didn't bother. Now, I want you to look up here. If I had 1 mole of this, how many moles of this would I need?
2.
So what
then
did
we
you do with the 1 to get to the 2?
multiply it by 2.
So I
So
should
we
multiply
multiply
this by 2.
that number by 2.
Now, be aware, you should ask your teacher, do you need to see units? So, for instance, does he need to see multiplies by 2 moles of HNO3 divided by 1 mole of BaOH? You should ask your teacher if you're going to lose marks by not including this.
Wait, not including what?
What I just wrote down right there. This is the mole ratio represented in the equation up here that you just told me I have to multiply by 2. But I want you to ask your teacher if he needs to see this bit of information.
She probably likes it, but if I get the right answer, I don't think she really cares.
Okay, that's interesting. Okay. Anyway, so take that number and multiply it by 2.
Yeah, okay. I did that and it's 0.012. No, 0.011 or
No,
0.01029
no, no. I want you to don't round up. It's 0.1.
0.01092.
Okay, that's interesting. You told me it's 0.00546.
Yeah, times 2.
Yeah, okay. Okay, you are correct, sir.
Yeah.
There we go. Okay, so that is now the moles, not of BaOH, but now we figured out moles of HNO3. Now they've told me that the amount of liters of that, and when it's titration, you don't have to add the liters. Now I have moles, and they've told me that this many liters of an HNO3. This many, but they told me milliliters. How many liters is that?
That's 25 milliliters, so that's 0.025 liters.
Right. So it's this many liters. Now, do you notice the word moles here?
I don't get what you mean by
Okay, but
notice.
just you see that I've written the moles here.
Oh
Do
yeah,
you see that I've written liters here?
yeah.
Do you remember what moles divided by liters is equal to? And
Concentration.
aren't they looking for, okay, when they see, okay, there's another word for concentration. When they give you these square brackets, that means concentration. Okay, so
Oh,
watch for that.
that's
Find
good
the
to know.
square bracket means find the concentration. So that means if I take the moles I just found and divide it by the liters, I should get the concentration.
Yeah.
Now be careful, in titration, you don't have to add the two volumes, but in other situations when you're mixing two things into a total volume, you are supposed to. But in titration, you don't have to.
Mm-hmm.
All right. So what happens when you take 0.01092 and divide it by 0.025?
Wait, I'll do that now.
Yeah.
Divided by 0.025 equals 0.4368.
And that's big M, moles per liter. You can say moles per liter, but you need to include some sort of unit. If you just say the number, you're going to lose marks for sure. So you can
Yeah.
say big M or moles per liter, both are acceptable. Good.
Yeah, equals.
Whatever number you just said, moles per liter of HNO3. So we did sort of a mole bridge here too, but you have to understand titration and what they're asking. When two things are titrated, they eliminate each other, all their acid and base, and it's about they eliminate each. Oh, actually, yeah, they eliminate each other based on their mole ratio. So for every we needed 2 moles of HNO3 to neutralize 1 mole of BOH2, which is why we had to multiply by 2 at one point. They're tough questions. You should do a few of them. Does your teacher give you an answer sheet to compare to see if
All
you got it?
complex stoichiometric.
Yeah. But notice
So,
each time we're doing this multiplication division, and it's about a mole connection in the equation, the moles in the equation. So it's a methodology that repeats consistently. So once you learn how to do it, it's not too bad. The reason I tried to teach you those fractions and the units is because the units can lead you to the answer.
oh yeah, that makes sense.
Yeah. You just always use the fraction which has the unit that you're looking for on the top. Okay, I think we're out of time.
Yeah, I think we
I,
finished.
I would
So
like, well, we didn't finish, but I would like you to circle the stuff that's really, I'll try to do as many videos as I want. I'm just not confident you have time to watch videos. And
I do have some time tomorrow.
it
If you,
all
I'll
comes,
watch the video you sent to me earlier,
yeah, it all
and then
comes down to practice though. Like you can watch
yeah,
videos till you're
obviously,
dead
because yeah,
because you have to be able to repeat it under the pressure of an exam.
yeah.
Okay,
So,
was that helpful at all?
oh, that was super helpful.
Okay,
Thank you
good.
so much.
I'm
And I'm
always
glad you
worried.
put that whole strategy you gave for that other one.
Yeah, that works every time. You just have to remember if you come up with a 0.5, you have to
Times it
you
by
have to
two.
times it by 2. If it comes out with a fraction over 3, don't divide it. Just leave the 3. You have to multiply it by 3.
Yeah.
You'll figure it out. All right.
What do you
See, huh?
that strategy if I forget?
Calm down. Breathe 10 times. Close your eyes and think of girls, and your brain will unlock. Or I shouldn't assume. Close your eyes and think about anything you want, and your brain will unlock, and then you go, oh, I got it. Or do
Okay.
do what you've always done. Go do the easy questions first.
Yeah.
Your brain will work on it in the background. You go, oh yeah, I remember that guy. He said concentrations moles per liter. Oh yeah, I remember. It's out. I gotta do A, B, C. I would practice the A, B, C, D. I sent you a video on it. Just twice. Just practice it twice so you get it.
Yeah. Wait,
You know?
you sent me a video on
Yeah,
the
I sent
ABC.
it to you like the first day. I sent you a
Oh,
few.
really?
I sent you a ton, buddy. I'm the only guy with my last name that's sending you emails, so you should probably check.
Yeah, the only loans.
Yeah, it's actually pronounced
Okay,
Lawrence, but
well,
that's okay.
I basically have I'll just pull up my classroom because I want to ask you a quick
Oh
question.
yeah, sure.
The So yeah, I have organic chemistry,
Oh God, yeah.
solutions chemistry
Mm,
are the two ones that like
God, organic chemistry. I don't even like.
this.
Organic chemistry is all memorization.
Wait, organic chemistry is like naming, right?
Yeah, alkenes, alkalines, alkynes. But it's you got to memorize the sort of like connection. One has single bond, one has double bond, one has triple bond. It's all memorization. There's very little I can help you with that because I'm all about the math.
Yeah, well, I was pretty good at organic chemistry.
Good.
So I think I just need to do some review and some practice.
So
And
here,
then
let me turn you on to a guy that'll help you a lot more than I will. Here we go. Ready? There's how it can help you. I'll send you a couple of this guy right away. Okay. Now, trust me, this guy is really good for that. So YouTube, and you can play YouTube at twice the speed, right?
oh, smart. Yeah, I'll
Yeah.
definitely do that. I always forget.
Organic chemistry questions. There we go. This guy right here. Let's see if he pops up first. No, he did. There he is. The organic chemistry tutor. So, right here, he is very good.
This multiple choice final.
Let
But
me just
he's a slow talker. See, 2 hours. So you got to go right over here to settings and hit the double speed.
okay.
So I'm going to send it to you right now. And then he's got a whole bunch of stuff. Organic chemistry YouTube. There we go. That's that one. Let's see if he's got a few more in here. Very good for that. Yeah, he's got one organic chemistry exam.
In this
And he gives 1,000 examples. That's why he takes so long. And that's probably your best one.
Yeah,
There's one review. There's organic chemistry synthesis and reaction. It all depends on what depth you're taking the course. So I'll send it.
yeah. So for tomorrow,
Yeah?
I should watch I should look at the organic chemistry tutors videos. I should watch the videos you sent me,
Yeah.
or as much of as them as I can, and then do practice on stoichiometry
If that's your
and
weak
a
point.
couple.
If that's your weak point. I would say
I think it's good to,
the tough one's going to be limiting reactions, the ones that are just after the titration.
yeah.
Okay.
Yeah, so then practice limiting reactants.
Yeah. Yeah, they're tough one. The titration and limiting reactions. All right. And then if you see questions that are boggling your mind, we'll focus on that tomorrow. But I'll try to send you some videos between now and tomorrow.
Well, thank you so much for this.
Yeah, good. It's tough. When's your exam?
Wednesday.
Yeah. Just don't cram your head so bad that you get flustered. At a certain point, you got to just say, forget it. That's good. Because there's such a
Sure.
thing as overstudying. All right.
Actually,
Yeah, there is. Yeah.
never heard of that.
It's just stress. It's just too much stress.
True, that makes sense,
Yeah.
actually.
All right. So if something comes to your head, you can shoot a question at me by email and say, I don't get this one. I can do a video on it as well. Okay.
Okay.
All right. See you, Alex.
Yeah, see you later.
Okay.